Okay, folks, so what if we need to rationalize a denominator and we have square roots all over the place? So this is straight out of the homework. If you'll remember, when you rationalize a denominator that has addition or subtraction, so right down here in the denominator I have the square root of 7 minus the square root of 6. Anytime you add or subtract in the denominator that you need to rationalize, you need to multiply by the conjugate. So I'm going to multiply by the fraction, the square root of 7 plus the square root of 6. And what you're going to see what's going to happen to that. That's going to get rid of my square roots. But you also have to do it in the numerator. The square root of 7 plus the square root of 6. Okay? Now what may help is some parentheses. You know what I'm going to do? I'm going to end up foiling. You know, FOIL, multiplication of binomials, first, outer, inner, last, all of this. And that's why this problem gets ugly. So here we go. I'm going to multiply the square root of 3 times the square root of 7. Now, you know you can multiply square roots together if they're the same root. So those are both square roots. So that's going to be the square root of 21. Then I'm going to multiply the square root of 3 times the square root of 6. So that's going to be the square root of 18. Okay? Now here, I'm multiplying 3 times each of those. When I multiply 3 times the square root of 7, one's out of the square root and one's underneath. So I'm still multiplying them together, but I can't say that's the square root of 21 or anything like that, and I almost did it. Hold on a minute. That's not the square root of 21, right? That's just the square root of 7, and that's the point I'm trying to make. I just have to do 3 times the square root of 7. And then when I multiply 3 times the square root of 6, it's literally just 3 times the square root of 6. Now in the denominator, I'm going to do a similar thing. I'm going to multiply the first times the first. That's what FOIL stands for. First times first. Square root of 7 times square root of 7 is the square root of 49. If you're thinking, isn't that just 7? Yes, I'll simplify that in a minute. Square root of 7 times the square root of 6. Those are both under a square root, so that's the square root of 42. Then I'm going to move over to the next term. So that's negative square root of 6 times the positive square root of 7. That's negative square root of 42. All right, and then negative square root of 6 times positive square root of 6 is negative square root of 36. No need to do extra steps, okay? FOIL all that out, write down exactly what you have. Then simplify if possible. So if you'll notice, this positive square root of 42 and this negative square root of 42 just cancel out. That should always happen when you rationalize a denominator with addition or subtraction, with a binomial term in the bottom. That's exactly why we multiply by a conjugate. In other words, we change the sign, change the operation, really. Subtraction turns into addition, so those middle terms will cancel out. Okay? Now, what else could I possibly do? Well, looking at the numerator, y'all, there's nothing we can do, not really. I can rewrite the square root of 18 as the square root of 9 times the square root of 2. That helps a little bit, and I'll do it, but I can't add any of these together. They're not like terms. So right now in the numerator, I still just have the square root of 21 plus, like I said, the square root of 18. I'm going to write it as the square root of 9 times the square root of 2. Why did I do that? Because the square root of 9 is 9's a perfect square, so I'll be able to take the square root of that in a minute. Plus 3 square root of 7 plus 3 square root of 6. But in the denominator, this is going to look much better. The square root of 49, that's 7. The square root of 42 is canceled. We were talking about that, and minus the square root of 36 is 6. You know what? That just leaves a 1 in the denominator. Ooh, that's nice. Okay, so now that's a 1. The square root of 21 plus 3 square root of 2 plus 3 square root of 7 plus 3 square root of 6. And notice I'm just saying 3 square root of 2. That's really 3 times the square root of 2. Now divided by 1, that's going to equal my final answer. And there's no perfect order to write these in as long as you have all 4 terms. So the square root of 21 plus 3 square root of 2 plus 3 square root of 7 plus 3 square root of 6. That's your final answer. Now something to look out for, this problem didn't end up that way, but I have seen problems that end up with a negative in the denominator. What do you do with that? 2 options. One is not leave it in the denominator. That's not one of the options. You cannot leave it in the denominator. if this happened to be a negative, this 1 in the bottom, take the negative in front of the fraction. So you would have a whole negative in front of your answer. Well, in this case, we don't have a fraction, right? Because of the 1. If that were a negative 1, it would change all of these signs. So be real careful if you have a negative in the denominator, don't leave it. But my intention here was to show you one of these homework problems that had a square root and then plus another square root or minus another square root, and that's exactly what this had. And so this would be, this whole thing is your final answer. Why can't I add any more of this together? Because these are all different square roots. And remember, different square roots you can't add together. I can only add a square root of 21 to another square root of 21. I can only add a 3 square root of 2 to another square root of 2, and none of these square roots match. So we are done with this problem. Hope this helps. Always contact me if you have any questions, okay? Have a great day.